Good day everyone, I am Diana Rose Asfaro and today I am going to discuss to you my Performance 8 which is all about antennas. My discussion is all about my name which is DSF. D stands for Batwing Antenna, S for Slatted Waveguide Array, F for Rhombic Antenna. So what is batwing antenna? A batwing or super turnstile antenna is a type of broadcasting antenna used at VHF and UHF frequencies, named for its distinctive shape which resembles a batwing or bow tie. This is what a super turnstile looks like. Just take a look at these two figures. Figure 1 shows the arrangement of super turnstile array with the red dots being the feed points. In Figure 2 shows the stacked turnstile array used in satellite communications. This antenna is infinitely long in both directions, so that wavelength never comes into the equation. As a result, this antenna would theoretically have an infinite bandwidth, because if it works at one frequency, it must work at all frequencies, because the antenna looks the same at all wavelengths. Now, let's proceed to the advantages and disadvantages. Advantages are high gain is achieved by stacking. Super turnstile produces high gain output. Better directivity is achieved. The disadvantage is the radiation power is 3 dB below the maximum radiation of a half-wave dipole radiating the same power. The applications are: it can be used for VHF communications. It is used for FM and TV broadcasting. It is used in military communications. And it is used in satellite communication. Next, let's proceed to the slotted waveguide array. Slotted antenna array used with waveguides are popular antenna in navigation, radar, and other high-frequency systems. They are simple to fabricate, have low loss, high antenna efficiency, and radiate linear polarization with low cross-polarization. These antennas are often used in aircraft applications. This is the formula in slotted waveguide array. In the above, F is the frequency of interest, K is the wave number, and EO is a constant that specifies how much power is added to the waveguide. On the top wall of the waveguide, where the slots are, the induced currents will be this equation. Radiation occurs when the currents must go around the slots in order to continue on their desired direction. As an example, consider a narrow slot in the center of a waveguide, as shown in the picture above. In this case, the C component of the current will not be disturbed because the slot is thin, and the C current would not need to travel around the slot. Hence, the X component of the current will be responsible for the radiation. However, at this location, X is equals to A over 2, the X component of a current density is 0. No current and therefore no radiation. As a result, slots cannot be placed in the center of the waveguide. In here, the front end, the open face at the Y is equals 0 in the XZ plane is where the antenna is fed. The far end is usually shorted. The waveguide may be exited by a short dipole page or by another waveguide. We have here the equivalent circuit model of the common slotted waveguide antenna. The waveguide itself acts as the transmission line, and the slots in the waveguide can be viewed as parallel shunt admittance. The end of the waveguide is short-circuited. The last slot is a distance d from the end, and the slot elements are spaced a distance L from each other. So now, let's proceed to a rhombic antenna. What is a rhombic antenna? It is the type of antenna which is formed by connecting long wires in the orientation of a rhombus. These are highly directional broadband antenna that radiates maximal power along the axis. This is the design of a rhombic antenna. The two sides of rhombus are considered as the conductors of a two-wire transmission line. When this system is properly designed, there is a concentration of radiation along the main axis of radiation. In practice, half of the power is dissipated in the terminating resistance of the antenna. The rest of the power is radiated. The wasted power contributes to the minor lobes. These are the advantages and disadvantages of rhombic antenna. Advantages are input impedance and radiation pattern are relatively constant. Multiple rhombic antennas can be connected. Simple and effective transmission. The disadvantages are wastage of power in terminating resistor, requirement of large space, reduced transmission efficiency. The applications are: it is used in HF communications, it is used in long-distance skywave propagations, and it is used in point-to-point communications. So that's it for today. Thank you and have a blessed day.